Hello everyone, welcome in a new video. In this video we are going to understand about HRRN scheduling algorithm. HRRN means highest response ratio next scheduling algorithm. So what is the scheduling criteria here? So the scheduling criteria is very simple. Scheduling criteria says that we basically do here to scheduling a process is that whosoever process have a smallest burst time, we select that process for the execution. Whosoever have a smallest burst time, we select that process for the execution. Okay, so this is what we do in this scheduling in this scheduling algorithm. So if you recall, the same thing we are doing in SJF as well. In this scheduling algorithm as well, shortage of a scheduling algorithm, we are doing the same thing. We are selecting that process who have a smallest burst time. Okay, so we are doing that thing in SGF as well. So what is the difference between these two scheduling algorithms? So the difference is we are choosing the smallest response ratio. We are choosing a smallest response ratio. Okay, so the scheduling criteria for this particular algorithm is that response ratio. Okay, is what is a response ratio. Now what is a response ratio? RR basically define the response ratio. Response ratio is W plus S by S. Now what is W? W denote is a wait time or waiting time, and S here denote the burst time, and sometime if there is also written in a question like service time. Okay, so service time or burst time is basically the same thing. Okay, so what we are going to do in HRRN, we are selecting according to a response ratio. In this we are selecting according to the response ratio. And how we calculate the response ratio? The formula is waiting time plus burst time divided by the burst time. And if and we are finding these things for the different processes, and whosoever process have a highest response ratio, we select that process for the execution. So what is the scheduling criteria? Scheduling criteria is the response ratio. Basically we are selecting according to the response ratio. Now what happen if there is a tie between a response ratio? Because there is a possibility that you find the response ratio like 5, and for the P1 process, and for the P2 process the response ratio is 10, and for the P3 process response ratio is 5. So there is a tie between the two processes. So what happens if there is a tie? If there is a tie, we do same thing that what we do in SJF scheduling algorithm. If tie, then SJF criteria will be applied. Now what is the criteria? Those who have a smallest burst time will get a CPU first. So because response ratio is basically we find response ratio with the help of burst time, so definitely burst time is given in a question. Let's say that for the P1 process burst time is 10, and for the P5 process burst time is 2. So definitely we are going to select P5 process and then P1 process because burst time is lower. This is what we do in SGF as well. Those who process, we selecting those process who have a smallest burst time. Okay, so this is what a scheduling criteria of HRRN, highest response ratio next. Now another thing is, what type of algorithm is this? There are two type of algorithm: preemptive, non-preemptive. HRRN is basically a non-preemptive type of algorithm. HRRN is a non-preemptive type of algorithm. What does that mean? That means if process acquires CPU, it will not leave a CPU until it fully executed or it completely executed. Okay, this is what a meaning of a non-preemption means. Let's say that you have a CPU. Let's say P1 process is running in a ready queue. We have a ready queue as well. P1, P2, P3, P4, P5. Let's say these 4 processes are available in a ready queue. Okay, now P1 process is running. P1 cannot leave a CPU. P1 will not leave a CPU P1 will not leave a CPU until P1 is successfully completed. If P1 is completed, then P1 terminate. Neither P1 cannot leave the CPU. So this is what a meaning of a preemption, non-preemption. Okay, preemption means P1 is running and there is a high preemptive process, high valuable process. So what operating system do? Operating system snatch the CPU from a current running process and provide CPU to the priority preemptive process, important process. Okay, so this is what a meaning of a preemption. Non-preemption, process acquires CPU, it execute till the complete of the particular task, and then after the completing of the task, then it leave the CPU and other process then get a CPU. Okay, so this is a non-preemptive process. Now we understand so many things about HRRN. Now what we have to do is we have to solve a question now. So we have a processes P1, P2, P3, P4 and P5. We are going to take 5 processes. Arrival time is like 0 to 4, 6, 8. So this is what an arrival time. After that burst time is like 3, 6, 4, 5, 2. So this is what a burst time is. Now what you have to do is you have to find out the average turnaround time and average waiting time for this particular question. Now for finding that thing, first of all what we have to do is we have to find out the completion time, we have to find out the turnaround time, we have to find out the waiting time. So we need 3 things to find out the average TAT and average waiting time. Okay, so we need these 3 things. So we need to calculate. So for that we need to make a Gantt chart. We have to make a Gantt chart. Now in this particular type of scheduling algorithm, how we select a process? We are selecting a process according to a response ratio. And the formula of response ratio is W plus S by S. So the formula is this, and now we have to choose a process according to a response ratio. First of all, Gantt chart will start from 0. At 0, how many processes are available? Only one process available, P1. So definitely there is no need to find out anything, because if there is only one process, we have to take that process. Okay, 0 to 3. Okay, why I write 0 to 3? Because and here you can see that at 2 arrival time we have one process as well. But why I write 0 to 3? Because it's a non-preemptive process. It's a non-preemptive process. If process get a CPU, it will execute completely and then terminate. Now we have 3. So P1 is successfully completed. We have 2 processes available, P2 and P3. Okay, so we have only one process available, P2, whose burst time is 6. So definitely P2 will get a CPU. So 6 and 3 is become 9. 6 and 3 become 9. Now after 9, what basically happen is P2 process is completed. Now at 9 arrival time, we have 3 processes available, P3, P4 and P5. 3 processes are available. Now what we have to do is we have to select the process according to the response ratio. Okay, how we find out the response ratio? So we have to find out the response ratio for all the remaining processes. If there are 10 processes, then we have to find out response ratio for all the 10 processes, and whosoever have a greater response ratio, we will select that process. Okay, so response ratio for P3, first of all we are going to calculate what is the formula, waiting time. Now how we calculate the waiting time? Waiting time is basically calculated by the arrival time. Here arrival time is what? 9 minus arrival time basically arrival time of basically the next process, or you can say the completion time of the current process, or what you can say anything. Okay, so we have to say 9. We have to select 9. Okay, whether you say the arrival time for the rest of the processes, or you can say the completion time of a previous process, which is P2. So completion time of P2, 9 minus what? The arrival time of P3. So P3 is this. So arrival time of P3 is what? 4. So 9 minus 4 plus burst time. What is the burst time? Burst time of P3 is what? 4. Burst time of P3 is 4 divided by the burst time, which is 4. So 9 minus 4 is 5. 9 minus 4 is what? 5. 5 plus 4, 9. 9 divided by 4, it becomes 2.25. So this is a response ratio of P3. Now we have to calculate response ratio for P4. What is this? The completion time of the current process, which is 9 minus the arrival time of P4 which is 6, so 9 minus 6 plus the burst time which is 5 divided by 5. So 9 minus 6, 3, 3 plus 5, 8, 8 divided by 5 is 1.6. Response ratio for P5. Now for the P5, what is the response ratio? Completion time which is 9 minus the arrival time 8 plus the burst time which is 2 divided by 2. So it becomes 1, 1 plus 2 is 3 by 2, 3 by 2 means 1.5. So here you can see that basically the response ratio of all the three things. There is a tie? No, there is no tie. So we have to do the basic approach. What is that? Whosoever have a highest burst time, those process who have a high burst time, we have to select that process. So now P3 is selected. P3 is selected. So it's a non-preemptive process. So P3 will execute completely. The burst time is what? 4. So 9 and 4 it become 13. 9 and 4 become 13. So P3 is also completed. Now after that, two process is left, P4 and P5. Now what we have to do is, we are not gonna see these things now, because the completion time of the previous process is changed. Now the completion time is 13, not 9. So we have to calculate response ratio for these two process as well. Okay, so response ratio for P4 when the completion time of a previous process is 13. So what it become? 13 minus the arrival time which is 6, 13 minus 6 plus the burst time which is 5 divided by 5. 16 minus 13 minus 6 is become 13 minus 6 will become okay, so 12, 7 plus 5 divided by 5 make it 12. Okay, so 12 divided by 5 which is 2.4. 12 divided by 5 which is 2.4. Now we have to calculate the response ratio for P5. Response ratio for P5. So it's completion time of a previous process which is completion time of the current process or arrival time for the next process which is 13 minus the arrival time of P5 which is 8. So 13 minus 8 plus 5 divided by, okay, so 13 minus 8 plus 2, not 5. 13 minus 8 plus 2 divided by 2. So 13 minus 8, so 13 minus 8 it will become 5, or 5 and 2 becomes 7 divided by 2. 7 divided by 2 is 3.5. So definitely we have to select that process who have a highest response ratio. So this one P5 will have a highest response ratio. P5 is selected. So burst time is what? 2. So 13 and 2 become 15. 13 and 2 become 15. Okay, and after that what we have to do? We have only one process left, so there is no need to do anything, because there is only one process left which is P4. So burst time is what? 5. So it becomes 20. It becomes 20. Okay, so this is how the Gantt chart is basically made. Now you can easily find out the average turnaround time and average waiting time, because you know everything. Okay, so completion time for P1 process is what? 3. Completion for P2 is 9. For the P3 is 13. P4 is 20 and P5 is 15. Turnaround time, completion time minus arrival time. Waiting time is what? Turnaround time minus the burst time. So you can calculate these things and comment down the average turnaround time and average waiting time for this particular question. Okay. So we understand this question as well, every HRRN scheduling algorithm as well. Now we have to talk about the advantages and the disadvantage of the scheduling algorithm. Advantage. Now what is the advantage of this scheduling algorithm? The advantage is, because what is the drawback in SJF? Because this scheduling algorithm doing the same thing, it select that process who have a smallest burst time. So you can see that it select that process who have a smallest burst time. What the thing basically this algorithm solve that SJF doesn't do? The thing is that those who have a highest burst time will get the CPU. Those process who have a high burst time will get a CPU, because this is what a disadvantage in SJF is, that if there is a lot of process coming in a ready queue, and there is a one big process is also there, but what operating system do? If he apply SJF scheduling algorithm, it select that process who have a smallest burst time, so the big process will go in a starvation. the big process go in a starvation. So this problem is basically solved in HNN because every process get a chance. What it do, those process who wait for a very long time, it what this HRRN do is basically select that process as well after some time, because this scheduling algorithm understand this thing that this process is wait for a very longer time. So what we have to do is we have to select this process. This is for that we are calculating the response ratio. Waiting time, this is what a waiting time is. So we are taking waiting time as well, so that those who have a high waiting time will get a CPU as well. Okay, so this is what the advantage here. So what is the advantage? No starvation, no starvation. Okay, so this is what advantage here, or what basically the advantage is that every process get equal chance, so there is no convoy effect as well, no convoy. Okay, so there is no convoy effect as well. So this is what advantage is. Now what is the disadvantage? Okay, disadvantage. So the disadvantage is there is no practical implementation of this particular scheduling algorithm. No practical implementation. Why? Because there is no, because operating system doesn't know about this scheduling algorithm, doesn't know about the burst time. Operating system doesn't know about the burst time. Okay, so this is what a disadvantage is. No practical implementation, but what is an advantage? No starvation and no convoy effect. So this is what happen in HRRN scheduling algorithm. Thank you for watching this video. Like the video and subscribe my channel.